November 16th, 1943. Aberdeen Proving Ground, Maryland. Major Thomas Henderson stood in the cold morning air, his breath forming clouds in the autumn chill as he watched two vehicles roll into the testing facility's main evaluation bay. The sky hung low and grey over the Chesapeake Bay, carrying the salt smell of the water just a few miles east. It was the kind of morning that made metal cold to the touch and reminded everyone that winter was approaching fast. One vehicle he knew well, the standard Willys MB Jeep that had become as familiar to American soldiers as their M1 rifles. Henderson had seen hundreds of them. He'd driven them himself across Aberdeen's punishing test courses. He knew every rattle, every quirk, every capability. The Jeep represented American automotive engineering at its most practical and effective. 60 horsepower of Go Devil engine wrapped in a frame that could handle anything the army threw at it. The other vehicle made him pause and stare. The captured German Kübelwagen looked like something designed by engineers who'd never seen a proper military vehicle. Its body panels were thin stamped steel, angular and crude, where the Jeep's body showed careful welding and substantial construction. Its wheels barely larger than a motorcycle's 14 inches in diameter compared to the Jeep's 16-inch combat wheels. The entire vehicle sat low to the ground, its profile more suited to a civilian runabout than serious military equipment. Under that angular hood sat an air-cooled engine producing just 25 horsepower, less than half what the Jeep's Go Devil put out. Henderson had read the intelligence specifications 3 times, certain there must be an error. 25 horsepower might work for a motorcycle or a very light civilian car. For a military vehicle expected to traverse combat zones, carry soldiers and equipment, and operate under the worst conditions imaginable, it seemed absurdly inadequate. Everything about German military doctrine said precision engineering meant superior performance. Their tanks were marvels of complexity that American engineers studied with mixture of admiration and concern. Their aircraft pushed technological boundaries with innovations American designers hadn't considered. Their weapons reflected meticulous craftsmanship and attention to detail that bordered on obsessive. The German reputation for engineering excellence was well earned through years of producing equipment that consistently impressed Allied intelligence analysts. But this little vehicle, with its bathtub-shaped body and bicycle tires, looked like something farmers might use to haul vegetables to market, not something Wehrmacht forces would trust with military missions. The contrast between German engineering reputation and this vehicle's appearance was jarring enough to make Henderson question whether this was really representative of German military equipment or some kind of field improvisation cobbled together from civilian parts. Henderson's mechanics gathered around the Kübelwagen, their faces showing the kind of professional skepticism that came from years analyzing enemy equipment. Technical Sergeant William Chen, who'd spent 15 years designing trucks for Ford before Pearl Harbor, convinced him that testing military vehicles served his country better, walked slowly around the German machine with his hands clasped behind his back. His expression suggested he was looking at a child's toy rather than actual military hardware. Corporal Robert Martinez, a former mechanic from El Paso who could diagnose engine problems by sound alone, knelt beside the rear-mounted engine compartment and peered inside. His whistle of disbelief carried across the testing bay. This is what they're fighting a war with? My grandfather's Model T had more guts than this thing. They'd tested captured Panzers that impressed with their engineering sophistication. The Panther tank's transmission, despite its reliability problems, showed mechanical complexity that pushed the boundaries of what was possible with 1940s manufacturing technology. They'd examined German half-tracks that demonstrated precision manufacturing with tolerances tighter than most American automotive plants could achieve. Even captured German small arms showed craftsmanship that made American mass-produced weapons look crude by comparison. This diminutive vehicle seemed almost comically inadequate by comparison. It looked like the kind of thing German engineers might have thrown together in a weekend as a proof-of-concept prototype, not something they'd actually put into mass production and deploy across every theatre of the war. Yet the intelligence reports told a different story that Henderson couldn't ignore. German forces had deployed over 50,000 of these machines across every front from North Africa's blistering deserts to Russia's frozen steppes. They'd used them in Poland during 1939, in France during 1940, across the Balkans, throughout the Mediterranean, and on the Eastern Front, where conditions destroyed most conventional vehicles within months. Somehow, this primitive-looking contraption with its underpowered engine had become as essential to the Wehrmacht as the Jeep was to American forces. More puzzling were the maintenance logs that had accompanied this particular vehicle when it was captured near Tunis during the final collapse of German forces in North Africa. The Kübelwagen had been in continuous service since March 1941, over 2.5 years of operation under combat conditions. Its odometer showed 38,000 kilometers, roughly 23,000 miles, of service across some of the harshest terrain on Earth. The maintenance log documented regular oil changes and routine service, but no major repairs, no engine overhauls, no transmission rebuilds, just basic maintenance that any mechanic with simple tools could perform in the field. Henderson had seen enough American vehicles to know that kind of service record was extraordinary. Jeeps regularly needed significant maintenance after a year of hard use. Their engines required rebuilds after 12 to 15,000 miles under combat conditions. Their cooling systems developed leaks. Their electrical systems failed. Their four-wheel drive transfer cases needed constant attention. The idea that this modest German vehicle had operated for over 2 years with nothing but basic service seemed to contradict everything Henderson understood about mechanical durability. Henderson climbed into the driver's seat, immediately noticing how the sparse interior contrasted with the Jeep's utilitarian but substantial construction. The seat was surprisingly comfortable, a bucket design that actually justified the vehicle's nickname, Kübelsitzwagen, or bucket seat car. But the door was just a thin metal panel. There was no padding, no insulation, no weather sealing that would keep rain or dust out. The dashboard held exactly 4 gauges: speedometer, fuel gauge, oil pressure, and that was it. No ammeter, no temperature gauge because there was no cooling system to monitor. The Kübelwagen felt light, almost fragile. Henderson weighed about 180 pounds, and he could feel the suspension compress noticeably when he settled into the seat. The steering wheel was thin metal with minimal padding. The pedals were simple pressed steel. Everything about the interior screamed minimalism taken to an extreme that seemed incompatible with military requirements. Its controls seemed too simple for serious military work. The gear shift was a floor-mounted lever with a straightforward H pattern, but the shift gates felt loose and imprecise compared to the Jeep's crisp mechanical feedback. The 4-speed transmission didn't have synchronized gears in first or reverse, a cost-saving measure that most American civilian cars had abandoned years earlier. When Henderson started that modest air-cooled engine, it hummed with a mechanical efficiency that suggested careful design. The sound was nothing like the Jeep's Go Devil engine, which rumbled with authority and power. The Kübelwagen's flat-4 engine made a distinctive thrumming sound, almost musical, as it settled into idle. There was no radiator fan whirring, no coolant circulating, just the steady beat of pistons moving in opposition and cooling fins drawing air past cylinder heads. But 25 horsepower against the Jeep's 60. Henderson couldn't imagine how German commanders expected this vehicle to perform real military missions. The power deficit was simply too large. The Jeep could haul 800 pounds of cargo and still maintain reasonable speed. It could tow artillery pieces up steep grades. It could push through deep mud by sheer force of engine torque. This German vehicle looked like it, would struggle to move its own weight across anything more challenging than smooth pavement. 3 months later, after comprehensive testing that would challenge every assumption about what made a military vehicle effective, Henderson would write a technical report that contradicted nearly everything American doctrine taught about automotive engineering for war. The primitive-looking German vehicle wasn't inferior. It was solving completely different problems than American engineers had ever considered. Problems about resource scarcity, logistics vulnerability, and the difference between maximum capability and optimal sustainability. Problems that American industrial abundance had allowed designers to ignore, but which German constraints had forced engineers to confront directly. The contrast began long before either vehicle reached Aberdeen's testing grounds. It started in 1938, when two nations approached the same challenge with fundamentally different assumptions about what modern mechanized warfare required. The parallel development stories revealed not just different engineering solutions, but different philosophies about the relationship between industrial capacity, military requirements, and strategic planning. The American story reflected optimism born from industrial abundance that had defined the nation's manufacturing sector since the late 19th century. In July 1940, when the U.S. Army issued specifications for a light reconnaissance vehicle, the requirements document read like a wish list from commanders who assumed unlimited manufacturing capacity and robust supply chains, stretching from American factories to any battlefield on Earth. The specifications were detailed and demanding. The new machine needed four-wheel drive because American doctrine emphasized cross-country mobility in all conditions. It needed a wheelbase under 80 inches and track width under 47 inches to fit inside transport aircraft to navigate narrow European roads. It needed to weigh less than 1,300 pounds empty, though that requirement would prove impossible to meet. Most importantly, it needed power enough horsepower to climb 60% grades, haul 800 pounds of cargo, tow 1,000-pound trailers, and maintain highway speeds while carrying heavy loads. The Army wanted a vehicle that could do everything: reconnaissance, cargo transport, weapons platform, ambulance, command vehicle, wirelaying, radio carrier, and anything else commanders might dream up. American military planning assumed that if you built one vehicle capable of performing 20 different missions, logistics would be simpler than managing 20 specialized vehicles. The assumption made perfect sense given American industrial capacity and the belief that proper supply chains could support whatever complexity the design required. Three companies responded to the Army's challenge, and their responses revealed different interpretations of what light reconnaissance vehicle meant. American Bantam Car Company delivered the first prototype in just 49 days, an engineering sprint that bordered on miraculous. The Bantam reconnaissance car, nicknamed the Blitz Buggy, weighed just under 1,300 pounds and proved that light vehicles could handle serious off-road work. But Bantam was a tiny company with limited production capacity, and the Army worried they couldn't manufacture vehicles in the quantities modern warfare demanded. Ford Motor Company submitted the Pygmy, powered by their own 40-horsepower engine. Ford brought manufacturing expertise and production capacity that dwarfed Bantam's capabilities. Their prototype was heavier than the Army wanted, but showed the kind of robust construction that suggested durability under combat conditions. Ford engineers had approached the problem by scaling down truck technology rather than developing something entirely new, which meant their vehicle benefited from decades of automotive engineering experience. But Willys Overland's entry changed everything and set the standard by which all subsequent light military vehicles would be judged. Chief Engineer Delmar Barney Roos had joined Willys Overland in 1936 with a specific mandate to rescue the struggling company through innovative engineering. Roos had worked for Studebaker and Marmon before joining Willys, and he understood that the company's survival depended on developing products that combined capability with affordability. When the Army issued specifications for a light reconnaissance vehicle, Roos saw an opportunity to save his company while serving his country. Roos developed the Go Devil engine specifically for military applications, though he understood it might have civilian uses after the war. The 2.2-litre inline four-cylinder engine wasn't revolutionary in its basic design. It used conventional L-head valve configuration and a cast-iron construction that any automotive mechanic would recognize. But Roos had optimized every component for reliability and durability rather than peak performance or manufacturing economy. The Go Devil produced 60 honest horsepower at 4,000 RPM, delivering 105 foot-pounds of torque at 2,000 RPM. Those numbers placed it at the top of its displacement class for American automotive engines. More importantly, the engine could sustain high loads continuously without overheating or wearing excessively. Roos had designed it to run at 3/4 throttle all day long if necessary, knowing that military use would be far more demanding than civilian driving. The cooling system used a pressurized radiator with a 4-blade fan that moved substantial air volume even at idle. The water pump was overbuilt compared to civilian automotive standards, using sealed bearings that could handle contaminated coolant and irregular maintenance. The thermostat opened early and wide, prioritizing cooling capacity over fuel economy. Every design decision reflected the assumption that cooling system failure in combat could be fatal, so reliability mattered more than efficiency. The electrical system featured a heavy-duty generator and a large-capacity battery because Roos knew the vehicle would need to start reliably under any conditions, and power accessories like radios that civilian cars never carried. The ignition distributor used waterproof components and shielding that suppressed radio interference critical for military communications, but unnecessary in civilian applications. Testing at Camp Holabird, Maryland during summer and fall 1940 proved Willys had created something special. The Army's Quartermaster Corps put all 3 prototypes through grueling evaluations that simulated combat conditions. The vehicles climbed steep grades, forded streams, traversed mud and sand, carried overweight loads, and operated continuously for days, at a time with minimal maintenance. The MB prototype outperformed its competitors in nearly every category. It accelerated faster, pulling away from the Bantam and Ford entries with authority that came from superior power-to-weight ratio. It climbed steeper grades, the Go Devil engine never straining even when hauling heavy trailers up test hills that stopped other vehicles. It hauled heavier loads without significant performance degradation. The robust frame and suspension could handle 800 pounds of cargo and still maintain reasonable speeds over rough terrain. Most importantly, that powerful Go Devil engine meant the Jeep never felt strained or overwhelmed, even under conditions that would disable lighter vehicles. When climbing grades, the engine had power reserves that allowed drivers to maintain momentum. When traversing mud, the engine could deliver sustained torque that kept wheels turning even when traction was marginal. When towing artillery pieces, the engine could pull loads that would overheat smaller power plants. The Army awarded Willys the mass production contract in July 1941, recognizing that the Go Devil engine provided capabilities the other entries couldn't match. The contract specified that Willys would produce the vehicle under the designation MB Military Model B, while Ford would produce identical copies under license to ensure adequate production capacity. The decision reflected American industrial philosophy. Identify the best design, then manufacture it in quantities that overwhelm any potential enemy. By December 1941, when Japanese forces attacked Pearl Harbor and thrust America into global war, American factories were already producing Jeeps at rates that would eventually total over 640,000 units. Willys Overland's plant in Toledo, Ohio ran 3 shifts, 7 days a week. Ford's factories in River Rouge, Michigan, and other locations added their massive production capacity. The vehicles rolled off assembly lines faster than the Army could ship them overseas, creating strategic reserves that meant damaged Jeeps could be replaced immediately rather than repaired in the field. The vehicle embodied American engineering philosophy perfectly. Maximize capability through abundant power, accepting higher weight and complexity, because industrial capacity could support whatever maintenance requirements emerged. Design for overwhelming performance rather than minimal adequacy, because American logistics could deliver the fuel, parts, and mechanic hours that high performance demanded. Build the best possible vehicle without worrying about resource constraints, because American industrial capacity made resource constraints irrelevant. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German story reflected very different realities. In January 1938, when Wehrmacht officials approached Ferdinand Porsche about designing a military vehicle, they faced constraints American planners never encountered. Germany's aluminum production couldn't support widespread use of lightweight metals. Steel allocations competed directly between vehicle manufacture and weapons production. Fuel availability remained uncertain even before war began. Most critically, German supply lines would stretch across conquered territories where replacement parts might take months to arrive, and maintenance facilities consisted of whatever tools individual units could carry. Porsche approached the challenge by adapting his Volkswagen People's car design for military use. The initial Type 62 prototype used a reinforced Beetle chassis with a simple open body, but early testing revealed problems. The vehicle weighed too much for its modest engine. Its ground clearance proved inadequate. Its durability under rough conditions disappointed. Wehrmacht evaluators who needed vehicles capable of sustained operations far from proper roads. Porsche redesigned the vehicle from the foundation upward. He created a new chassis with a completely flat underbody that would act like a sled when wheels sank into soft terrain. He added portal-type rear reduction hubs that increased ground clearance while multiplying torque at the wheels. He specified a ZF limited slip differential that would maximize traction from just 2 driven wheels. The body became a masterpiece of minimalist design. Stamped steel panels formed into angular shapes that required minimal welding and could be manufactured quickly. Every component served multiple purposes. The flat floor protected the drivetrain while providing slide-over capability in snow and sand. The high fenders accommodated maximum wheel travel. The open sides reduced weight while allowing easy entry and exit. By February 1940, when the Type 82 Kübelwagen entered full production, Porsche had created a vehicle that perfectly matched Germany's strategic constraints. The 985 cubic centimeter air-cooled engine produced just 23.5 horsepower, but it consumed minimal fuel, required no cooling system that could fail, and could be maintained using basic tools any mechanic understood. The vehicle's total weight of 1,600 pounds, over 800 pounds lighter than a Jeep, meant that modest power moved it adequately across terrain, where heavier vehicles became mired. German forces deployed the Kübelwagen everywhere Wehrmacht operations reached. In Poland, during September 1939, the vehicle proved its capability over roads that barely deserved the name. In France, during May 1940, it kept pace with armoured columns advancing through countryside where proper logistics hadn't yet arrived. In North Africa, where Rommel's Afrika Korps fought across deserts that destroyed conventional vehicles, the Kübelwagen's lightweight and air-cooled engine thrived in conditions that left water-cooled machines stranded. On the Eastern Front, where Russian winters froze lubricants and destroyed cooling systems, the simple Kübelwagen continued operating when more sophisticated equipment failed. American intelligence officers initially dismissed captured examples as evidence of German industrial weakness. Surely a vehicle with such modest specifications represented inferior engineering capability. The 25-horsepower engine seemed almost comical compared to the Jeep's 60. The rear-wheel drive layout appeared primitive against American four-wheel drive sophistication. Everything about the Kübelwagen suggested Germans couldn't build proper military vehicles, but field reports from captured German maintenance logs told a different story. Individual Kübelwagens had operated continuously for 18 months with nothing but routine service. They'd covered thousands of miles across terrain that destroyed Jeeps within months. Their air-cooled engines showed virtually no wear, even after extended high-temperature operations that would have warped water-cooled cylinder heads. Their simple construction meant repairs could be accomplished using tools carried in a standard toolkit. When the first captured Kübelwagens arrived at Aberdeen Proving Ground in November 1943, Major Henderson approached them with professional curiosity, rather than preconceived conclusions. His team had tested enough foreign equipment to know that appearance meant nothing. German engineering often produced solutions that seemed strange to American eyes but made perfect sense within their design context. The testing protocols Henderson developed would reveal whether the Kübelwagen represented inferior engineering or simply different engineering. Aberdeen's comprehensive evaluation facilities could measure every aspect of vehicle performance: acceleration times, fuel consumption, off-road capability, maintenance requirements, component durability, every factor that determined whether a vehicle could perform military missions effectively. Henderson started with the basics: pure performance metrics that would reveal how each vehicle moved, climbed, and maneuvered under controlled conditions. The Jeep ran first, establishing baseline numbers Henderson's team had measured dozens of times. 0 to 30 miles per hour on level pavement took 9.1 seconds. The Go Devil engine delivered power with authority that pushed the 2,400-pound vehicle forward with satisfying urgency. Top speed on Aberdeen's test track reached 65 miles per hour, though military governors typically limited field vehicles to 45 for safety and fuel economy. The Kübelwagen's performance told a completely different story. 0 to 30 required 14.3 seconds. The small air-cooled engine didn't roar with American mechanical confidence. It hummed steadily, never straining, but also never delivering the kind of aggressive acceleration American drivers expected. Top speed maxed out at 50 miles per hour, and even that felt optimistic for sustained operation. Henderson made notes without judgment. Raw performance numbers only revealed part of the picture. Off-road testing began on Aberdeen's standardized obstacle course, designed to replicate battlefield terrain. Deep mud sections, steep inclines, loose sand, water crossings, every challenge military vehicles faced in actual combat. The Jeep attacked the course with characteristic American directness. Its four-wheel drive and powerful engine pulled through obstacles that would stop conventional automobiles. It climbed grades by sheer force, using horsepower to overcome marginal traction. It bulled through mud by maintaining momentum and letting weight and power do the work. Henderson had seen hundreds of Jeeps complete this course. The vehicle's capabilities were well documented and thoroughly proven. The Kübelwagen approached obstacles differently. Its lightweight meant it didn't sink as deeply into soft terrain. Its flat underbody acted like a sled, distributing weight and allowing the vehicle to slide across surfaces rather than cutting through them. The limited slip differential transferred power between rear wheels intelligently, maximizing traction without the complexity of true four-wheel drive. Henderson watched as the German vehicle negotiated the mud section using 1/3 less throttle than the Jeep required. It didn't power through obstacles. It floated across them, using weight distribution and intelligent design to accomplish what the Jeep achieved through brute force. On steep inclines, the Kübelwagen climbed steadily at 8 miles per hour, while the Jeep attacked at 15. But after 30 minutes of repeated hill climbs, the Jeep's temperature gauge showed concerning readings. The water-cooled engine was working hard, generating heat that stressed cooling system capacity. The Kübelwagen's air-cooled engine maintained consistent operating temperature regardless of workload. It simply couldn't overheat because it had no cooling system to fail. The fuel consumption testing revealed the most dramatic differences. Aberdeen's standardized 100-mile course included highway sections, off-road terrain, and stop-and-go conditions designed to replicate realistic military operations. The Jeep completed the course in 2 hours and 45 minutes, consuming 15 gallons of gasoline in the process, 10.7 miles per gallon. Its performance had been aggressive and capable. The driver could maintain high speeds on pavement and attack obstacles without worrying about conservation. The Kübelwagen required 4 hours and 20 minutes to complete the same course, but consumed only 5.8 gallons, 17.2 miles per gallon. Henderson calculated the implications. Over a typical month-long operation covering 1,500 miles, a Jeep would consume 140 gallons of fuel. A Kübelwagen would consume 87 gallons. That 53-gallon difference represented weight, transport capacity, and logistics infrastructure. In theaters where fuel supply was uncertain, where transport capacity was limited, where every gallon required shipping across oceans or deserts, that efficiency advantage could mean the difference between completing missions or being stranded. But Henderson recognized the trade-off. The Kübelwagen's efficiency came at the cost of time. Missions that took the Jeep 3 hours required 5 from the German vehicle. In warfare, where speed mattered more than resources, where rapid advances could exploit enemy weaknesses, the Jeep's performance would be decisive. Henderson's initial assessment noted both vehicles' strengths within their respective design contexts. The maintenance testing revealed the most profound differences in engineering philosophy. Aberdeen maintained detailed specifications for servicing military vehicles. The testing protocols simulated combat damage and measured how quickly mechanics could restore operational capability. For the Jeep, a complete engine service required accessing systems distributed throughout the vehicle. The water cooling system involved radiator, hoses, water pump, thermostat, and fan, 6 major components that could fail independently. The electrical system used a complex distributor with points that required regular adjustment. The four-wheel drive transfer case added mechanical complexity that demanded specialized knowledge and tools. Aberdeen's standard service manual for the Jeep ran to 274 pages covering every system and subsystem. Major repairs required 53 different specialized tools. Mechanics needed training that took weeks to complete. Most critically, the service manual assumed access to proper facilities and equipment that might not exist in forward combat zones. The Kübelwagen's maintenance manual was 38 pages. Engine service could be accomplished using 12 basic tools, wrenches and sockets that fit in a canvas roll weighing less than 5 pounds. The air-cooled engine. There was no radiator to rupture, no water pump to fail, no hoses to leak, no coolant to contaminate. The electrical system used a simple magneto that generated ignition spark mechanically, eliminating the distributor points that required constant adjustment on American vehicles. Henderson's team simulated common combat damage. A damaged fan belt on the Jeep required replacing the belt and checking cooling system function 20 minutes if the belt was available. Indefinite delay if it wasn't. The Kübelwagen had no fan belt. Its air-cooled engine needed only unobstructed airflow. A damaged electrical component on the Jeep might disable the ignition system entirely, requiring specialized replacement parts. The Kübelwagen's magneto was self-contained and nearly bulletproof. Field repairs that would take hours on the Jeep took minutes on the German vehicle. Henderson recognized the strategic implications. The Jeep had been designed assuming proper support infrastructure. It expected mechanics with specialized training, supply chains delivering correct replacement parts, and maintenance facilities with appropriate equipment. When those assumptions held true, the Jeep's performance advantages made it superior for virtually any mission. But when those assumptions broke down, when units operated beyond reliable supply lines, when replacement parts took weeks to arrive, when mechanics had to improvise repairs using whatever materials were available, the Kübelwagen's simplicity became a decisive advantage. The cold weather testing revealed another crucial difference in design philosophy. Aberdeen's climate chamber could simulate temperatures down to -40 degrees Fahrenheit. Intelligence reports from the Eastern Front had documented catastrophic German equipment failures during Russian winters, but those reports focused on tanks and heavy vehicles. Henderson wanted to know how the Kübelwagen performed under extreme cold. Both vehicles were driven through artificial mud, then left in the climate chamber overnight at -10 degrees. The next morning, mechanics attempted to start engines and drive both vehicles. The Jeep started easily. Its battery and electrical system had been designed for cold weather operation. But when the driver engaged the clutch and attempted to move forward, the vehicle barely budged. Mud had frozen around the wheels and suspension. The water in the cooling system, even with antifreeze, had formed ice crystals that restricted flow. Henderson's team needed 35 minutes of careful work with warm water and scrapers to restore the Jeep to full mobility. The Kübelwagen's air-cooled engine started with similar ease. The driver let it warm briefly, then attempted to move. The vehicle rolled forward without hesitation. Some ice had formed around the tires, but the lightweight and rear weight bias meant the driven wheels had enough traction to break free. Within 8 minutes, the Kübelwagen was fully operational. Henderson immediately understood why German forces on the Eastern Front had continued using Kübelwagens even after suffering devastating losses. The vehicle's air-cooled engine simply couldn't freeze. Its lack of a water cooling system eliminated the single biggest cold weather vulnerability of automotive equipment. Its light weight meant it could break through ice accumulation that would immobilize heavier vehicles. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The towing and payload tests revealed the Jeep's most significant advantages. American doctrine emphasized versatility. The Jeep needed to tow artillery pieces, haul ammunition, transport heavy equipment, and serve as a light cargo truck when necessary. The Go Devil engine's 60 horsepower and substantial torque meant the Jeep could pull 1-ton trailers up steep grades. Its robust frame and suspension could handle 800 pounds of cargo without significant performance degradation. Most Jeeps deployed with pintle hitches as standard equipment. The Kübelwagen had been designed with completely different priorities. Most examples didn't even include a trailer hitch. When they did, towing capacity was limited to a few £100, enough for a small equipment trailer, inadequate for serious cargo work. The vehicle's 1,600-pound weight and modest power meant heavy loads quickly overwhelmed its capabilities. Henderson documented this disparity carefully. In missions requiring heavy towing or cargo capacity, the Jeep was unquestionably superior. But he also noted how rarely captured German maintenance logs showed Kübelwagens being used for heavy hauling. German forces seemed to have different vehicles for different missions. The Kübelwagen served primarily as a reconnaissance, liaison, and personnel transport vehicle. Heavy hauling went to specialized trucks. American forces expected the Jeep to do everything. The durability testing produced mixed results that surprised Henderson's team. Conventional wisdom held that American vehicles were overbuilt and German vehicles were fragile. The testing suggested a more nuanced reality. The Jeep's water-cooled engine showed stress patterns typical of high-performance automotive equipment. Bearing wear indicated regular high RPM operation. The cooling system had been designed with adequate but not excessive capacity. Most critically, the complex four-wheel drive system required regular maintenance to prevent premature wear. After 500 hours of simulated combat operations, the Jeep needed significant service, not repairs, but preventive maintenance that consumed mechanic hours and required replacement parts. The Kübelwagen showed remarkably little wear. The air-cooled engine's internal components measured within factory specifications. The simple rear-wheel drive system showed minimal degradation. Most surprisingly, the vehicle's stamped steel body panels, which had looked cheap and flimsy, had proven remarkably resistant to damage. The thin metal dented rather than tearing, and most dents didn't affect function. Henderson's preliminary assessment noted that both vehicles reflected their respective design philosophies perfectly. The Jeep maximized immediate capability at the cost of complexity. The Kübelwagen optimized for sustained operation under austere conditions at the cost of raw performance. The comparative analysis Henderson compiled in early 1944 went far beyond simple vehicle performance. It revealed two fundamentally different approaches to mechanized warfare and the engineering philosophies that supported them. American doctrine assumed logistics superiority. The industrial base could produce unlimited vehicles, ship unlimited fuel, and deliver unlimited replacement parts to any theater of operations. Under these assumptions, designing for maximum capability made perfect sense. Why limit vehicle performance when the logistics infrastructure could support whatever maintenance and supply requirements emerged? The Jeep embodied this philosophy in every component. Its powerful engine delivered capability that exceeded most mission requirements because engineers knew American logistics could supply the extra fuel consumption. Its complex four-wheel drive system provided capability that only mattered in extreme conditions because engineers knew trained mechanics and proper parts would be available. Its water-cooled engine provided smooth operation and high performance because engineers knew the cooling system could be maintained properly. German doctrine reflected very different realities. Wehrmacht forces operated at the end of supply lines that stretched across conquered Europe. Fuel deliveries were uncertain. Replacement parts might take months to arrive. Maintenance facilities consisted of whatever equipment could be transported to forward positions. Under these constraints, simplicity became more valuable than performance. The Kübelwagen reflected this philosophy with equal precision. Its modest engine consumed minimal fuel because German logistics couldn't guarantee abundant supply. Its simple rear-wheel drive eliminated complexity because German mechanics couldn't rely on specialized training or tools. Its air-cooled engine required no cooling system maintenance because German forces couldn't assume access to proper service facilities. Henderson's analysis examined production numbers that revealed the strategic implications of these different approaches. By early 1944, American factories had produced over 300,000 Jeeps. Willys, Overland, Ford, and other contractors were manufacturing vehicles faster than the Army could deploy them overseas. Production capacity exceeded demand, allowing the military to replace damaged vehicles immediately and maintain strategic reserves. German production told a different story. From 1940 through early 1944, Volkswagen had manufactured approximately 40,000 Kübelwagens. Production rates were limited by material allocations, labor availability, and bombing campaigns that increasingly disrupted German industry. Every Kübelwagen deployed to combat units represented resources that couldn't be used for aircraft, tanks, or weapons. German forces operated in a state of permanent equipment shortage, making the Kübelwagen's durability and maintainability critically important. The intelligence reports that crossed Henderson's desk during spring 1944 revealed how these different engineering philosophies played out in actual combat. From North Africa, where British forces had captured numerous Kübelwagens during Rommel's retreat, came assessments that mixed skepticism with grudging respect. British engineers from Humber Car Company had dissected a captured example and written dismissive reports about its crude construction and minimal sophistication. But British soldiers who'd actually captured Kübelwagens told different stories. The vehicles were comfortable over rough terrain. They could navigate soft sand that bogged down heavier equipment. Their air-cooled engines thrived in desert heat that stressed water-cooled systems. Most tellingly, captured Kübelwagens continued operating after British mechanics assumed they'd need major service. From the Eastern Front came reports of Kübelwagens operating in conditions that should have destroyed any vehicle. Russian winter temperatures that froze lubricants and shattered cooling systems barely affected the air-cooled German vehicles. Their light weight meant they could follow tracked vehicles across snow-covered terrain where heavier machines became immobilized. Individual units reported Kübelwagens with odometer readings exceeding 50,000 kilometers over 30,000 miles, with nothing but field maintenance. From Italy, where American forces were pushing north through mountainous terrain, came observations about tactical employment. German forces used Kübelwagens primarily for reconnaissance and liaison missions, where the vehicle's modest size and lightweight provided advantages. They didn't expect the Kübelwagen to haul heavy equipment or tow artillery. They'd designed their logistics around using the right vehicle for each specific mission. American forces expected the Jeep to do everything, and it generally succeeded because American logistics could support that versatility. Henderson synthesized these reports into an assessment that challenged conventional thinking about vehicle design. The Kübelwagen wasn't inferior to the Jeep in any absolute sense. It was solving different problems than American engineers had considered. Its apparent weaknesses, low power, rear-wheel drive, minimal payload capacity, were actually strengths within German operational constraints. Its simplicity meant it could operate independently for extended periods without external support. Its lightweight meant it could navigate terrain that stopped heavier vehicles. Its air-cooled engine meant it didn't have a cooling system that could fail. But Henderson also recognized that German engineering excellence couldn't overcome strategic realities. By mid-1944, Allied forces were advancing on all fronts with overwhelming material superiority. American industrial capacity was producing vehicles faster than they could be destroyed. German industry was struggling to replace losses, while Allied bombing campaigns destroyed factories and disrupted supply lines. The tactical situation was shifting in ways that favored American engineering philosophy. The Operation Overlord landings in Normandy during June 1944 demonstrated how American logistics superiority translated into strategic advantage. Within weeks of the initial landings, Allied forces had established supply infrastructure capable of supporting hundreds of thousands of troops. Fuel depots, maintenance facilities, replacement part stockpiles, everything needed to keep complex equipment operational existed in abundance on French soil. Under these conditions, the Jeep's versatility became decisive. American units used Jeeps for reconnaissance, cargo transport, artillery towing, ambulance service, and command vehicles. The vehicles performed every mission because American logistics ensured they had fuel, parts, and maintenance support. German forces fighting the defensive battles in France found their Kübelwagens increasingly vulnerable. The vehicles had been designed for offensive operations, where German units could move rapidly and live off captured supplies. Defensive warfare required different capabilities, heavier loads, more aggressive performance, greater versatility. The Kübelwagen's limitations became liabilities as German forces attempted missions the vehicle had never been designed to support. Henderson's June 1944 assessment noted these changing dynamics. The Kübelwagen had been perfectly adapted to German strategic conditions during 1940 through 1943. It had performed exactly as its designers intended, providing reliable transportation under conditions where more complex vehicles would have failed. But the strategic situation had shifted. Germany could no longer support offensive operations that played to the Kübelwagen's strengths. Allied material superiority was overwhelming German forces with equipment that didn't need to be perfect, it just needed to be abundant and adequately capable. The final assessment Henderson submitted to the War Department in August 1944 reflected sophisticated understanding of engineering within strategic context. His report avoided simple conclusions about which vehicle was better. Instead, it examined how each vehicle reflected its respective nation's industrial capacity, strategic assumptions, and operational requirements. The Kübelwagen represented brilliant engineering constrained by severe limitations. German designers had created a vehicle that maximized capability relative to available resources. They'd eliminated every unnecessary component, optimized for fuel efficiency and maintainability, and designed systems that could operate independently under austere conditions. The result was a vehicle that performed its intended missions admirably, despite having less than half the horsepower of its American counterpart. But those same constraints meant the Kübelwagen couldn't adapt to changing circumstances. Its modest power limited versatility. Its minimal payload capacity prevented heavy hauling. Its rear-wheel drive layout performed adequately in most conditions, but couldn't match four-wheel drive capability in extreme situations. The vehicle's excellence within its design parameters became a liability when missions exceeded those parameters. The Jeep represented American engineering philosophy, unconstrained by resource limitations. Designers had maximized capability without worrying about efficiency because American logistics could support whatever the vehicle required. The 60-horsepower engine consumed more fuel because American supply lines could deliver more fuel. The complex four-wheel drive system required more maintenance because American motor pools had trained mechanics and proper parts. The water-cooled engine needed more service because American infrastructure could provide that service. The result was a vehicle that could perform virtually any light vehicle mission American forces might require. It wasn't perfect. It consumed more fuel than necessary for many missions. It required more maintenance than simpler designs. It weighed more than optimal for some conditions. But American logistics superiority meant those inefficiencies didn't matter. What mattered was having a vehicle capable of doing everything, because American forces could afford the logistics penalty that versatility imposed. Henderson's assessment concluded with observations that would influence American military vehicle design for decades. Engineering excellence couldn't be measured in isolation from strategic context. The best vehicle was the one that best matched available resources to operational requirements. Sometimes that meant maximizing capability through complex systems and powerful engines. Sometimes that meant optimizing for simplicity and efficiency. The difference between success and failure wasn't which engineering philosophy was correct, but whether the philosophy matched the strategic situation. The Jeep had succeeded not because it was better engineered than the Kübelwagen, but because American industrial capacity could support its design philosophy. The Kübelwagen had succeeded at least until mid-1944 because German forces operated under constraints that made its efficiency and simplicity valuable. Both vehicles represented excellent engineering, but only American engineering operated unconstrained by resource limitations. By late 1944, the strategic dynamics Henderson had analyzed were playing out across every front. American forces advancing through France, Belgium, and Holland did so with logistics support that German commanders could barely comprehend. Every Allied division had more vehicles than entire German corps. Fuel consumption that would have crippled Wehrmacht operations barely registered in American logistics planning. Maintenance requirements that would have overwhelmed German motor pools were routine for American support units. The production numbers told the complete story. By war's end in May 1945, American factories had manufactured over 640,000 Jeeps. German production had reached approximately 50,000 Kübelwagens. The 12-to-1 production advantage reflected not just industrial capacity, but completely different approaches to mechanized warfare. German forces increasingly relied on captured Allied vehicles because their own production couldn't replace losses. American units regularly abandoned damaged Jeeps because replacement vehicles were so abundant that repairs weren't cost-effective. The engineering lesson wasn't that American designs were superior, but that American resources allowed design choices German engineers couldn't afford. Henderson's observations about the Kübelwagen's technical merit proved prescient in unexpected ways. After Germany's surrender, Allied occupation forces found themselves needing light vehicles to administer occupied territories. Surviving Kübelwagens were pressed into service across Germany, and Allied personnel discovered what German soldiers had known: the simple vehicles were remarkably effective for their intended purpose. British forces occupying the Volkswagen factory at Wolfsburg made an intriguing decision. Rather than dismantling German automotive capacity, they restarted Beetle production to help rebuild German transportation infrastructure. The same basic design that had produced the Kübelwagen would become the foundation for one of the most successful civilian automobiles in history. The Volkswagen Beetle's post-war success validated Ferdinand Porsche's original engineering philosophy. Simple, efficient, maintainable design could succeed in civilian markets just as it had succeeded in military applications, provided the market context matched the design assumptions. The American Jeep's post-war trajectory proved equally instructive about engineering philosophy and market context. Willys Overland recognized immediately that the Jeep's military success could translate into civilian markets. In 1945, the company introduced the CJ2A civilian Jeep, adapting the MB design for farmers, ranchers, and outdoor enthusiasts. The vehicle's versatility, its ability to plow fields, haul cargo, traverse rough terrain, and serve as mobile power source through its power takeoff, made it successful across rural America. But the Jeep's fuel consumption and maintenance requirements that hadn't mattered during wartime became significant concerns in civilian use. Farmers operating on tight margins cared deeply about fuel efficiency. Ranchers working far from service facilities wanted simplicity and reliability more than maximum capability. The civilian market wanted many of the characteristics the Kübelwagen had embodied: efficiency, simplicity, ease of maintenance combined with enough capability for practical work. Henderson's wartime analysis had identified this tension between maximum capability and optimal efficiency. American military vehicles had been designed assuming abundant resources and proper support. Civilian users faced different constraints that made German-style efficiency valuable. The post-war evolution of light utility vehicles reflected this insight. Later Jeep designs incorporated lessons learned from analyzing German engineering. The CJ series gradually became more efficient, simpler to maintain, and better suited for independent operation. By the 1970s and 80s, American off-road vehicles had absorbed many principles that had made the Kübelwagen successful: lighter weight, more efficient engines, simpler systems that owners could maintain themselves. The engineering legacy extended beyond specific vehicles to broader principles about design philosophy. Henderson's analysis had demonstrated that engineering excellence required matching design decisions to operational context. Maximum performance wasn't always optimal performance. Complexity wasn't always superior to simplicity. The best engineering solution depended entirely on the constraints and requirements of the specific application. These principles influenced American military procurement for generations after World War II. The Pentagon began evaluating vehicle designs not just on raw capability, but on maintainability, fuel efficiency, and suitability for extended operations with limited support. The recognition that American logistics superiority shouldn't be assumed in all future conflicts led to designs that balanced capability with sustainability. The Kübelwagen's influence appeared in unexpected ways throughout post-war vehicle development. Off-road enthusiasts building custom vehicles frequently used Volkswagen components, recognizing that the air-cooled engine and simple drivetrain offered advantages for recreational use. The dune buggy phenomenon of the 1960s and 70s drew directly from Kübelwagen design principles: lightweight, rear-engine layout, minimal complexity, maximum reliability. American military special operations forces occasionally procured modified civilian vehicles that emphasized many Kübelwagen characteristics. Lightweight for air transportability, simple mechanics for field repair, fuel efficiency for extended range. These priorities that had driven German design in 1938 remained relevant in specialized military applications decades later. Henderson's final observation in his 1944 assessment proved most enduring. He'd written that the difference between the Jeep and Kübelwagen wasn't about which engineering approach was correct, but about which approach matched available resources to mission requirements. That insight transcended World War II to become a fundamental principle of military engineering. In conflicts where American logistics could be assumed, where fuel flowed abundantly, where replacement parts arrived regularly, where trained mechanics were available, designs that maximized capability made sense. In conflicts where those assumptions didn't hold, where forces operated independently, where resources were constrained, where sustainability mattered more than peak performance, designs, emphasizing efficiency and simplicity, proved superior. The Kübelwagen had taught American engineers that sometimes the best solution wasn't the most powerful solution. Sometimes elegant engineering meant accepting constraints rather than trying to overcome them through brute force. Sometimes the vehicle that looked primitive actually reflected more sophisticated thinking about matching design to context. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.